Welcome to the DIY Honda Garage channel. The DTC P16F4 indicates a problem with the starter cut relay 2 control circuit, specifically showing low voltage. This code can trigger issues related to the vehicle's starting system. The starter cut relay 2 is a crucial component located in the engine compartment and is responsible for controlling power to the starter motor. If this circuit experiences low voltage, the vehicle may fail to start, indicating underlying issues. Before addressing this DTC, it is essential to review any general troubleshooting information that Honda provides for DTCs. The troubleshooting steps involve a systematic process to verify and address the faults to ensure your Honda Accord operates efficiently. DTC P16F4 refers specifically to the starter cut relay 2, indicating that there is an issue with the control circuit having low voltage. The starter cut relay 2 plays a pivotal role in enabling the engine to start by connecting power from the battery to the starter motor at the appropriate moment. Located within the engine compartment, it works in conjunction with the powertrain control module, PCM, to manage the vehicle's starting process. If the control circuit is underperforming or exhibiting low voltage, it can directly lead to starting issues. This could manifest as the engine being unresponsive when attempting to start. Understanding the role and location of this relay is essential for effective troubleshooting. The potential causes of DTC P16F4 can vary. Firstly, a shorted wire may exist in the starter cut relay 2 control wire, leading to low voltage in the circuit. Secondly, a malfunctioning powertrain control module, PCM, could be responsible for insufficient output voltage, thus impacting the relay's performance. Additionally, open circuit issues within the wiring can disrupt the flow of electricity, leading to a failure in the relay's operation. These causes are essential to consider during troubleshooting, as identifying them allows for targeted repairs and maintenance, ensuring a reliable starting system in the Honda Accord. Symptoms of DTC P16F4 primarily revolve around starting difficulties. The most notable symptom is the engine failing to start altogether, which can be frustrating for the driver. There may also be intermittent starting issues, where the engine starts inconsistently under various conditions. Furthermore, if the DTC is present, it specifies that the onboard diagnostics identified a problem in the starter cut relay 2 control circuit. Recognizing these symptoms early is critical. They can spare the owner from prolonged vehicle downtime and facilitate timely resolution of the underlying issues causing the DTC. In the first troubleshooting step for DTC P16F4, you need to check if the engine starts. Initiating this process involves attempting to start the vehicle. If the engine does start successfully, that hints the problem may lie deeper, and you can move on to step 2. However, if the engine does not start, it implies a failure within the starting system that needs to be resolved. Therefore, this step is crucial as it sets the direction for further diagnostics based on the initial results you encounter. The second troubleshooting step involves several important actions. First, you need to turn the vehicle to the off position, resetting the system. Next, using the Honda Diagnostic System, HDS, you will clear the DTC from the vehicle's memory. This is essential because it allows you to ascertain whether the issue is persistent by checking for newly generated codes. If DTC P16F4 reappears after clearing, it indicates a confirmed failure in the system. Conversely, if the DTC does not come back, it may suggest an intermittent issue, possibly due to loose connections or poor terminations that require further inspection. In step 3 of troubleshooting DTC P16F4, one needs to examine the starter cut relay 2 control line for potential shorts. First, ensure the vehicle is in the off mode. Following that, use the Honda Diagnostic System, HDS, to jump the SCS System Communication Serial Line, waiting over 1 minute to allow the reset to take effect. Afterward, disconnect the PCM connector A and the relay circuit board connector C. This disconnection allows you to check for continuity between specified test points effectively. By determining if there is any continuity between the points, you can ascertain if a short exists in the wire, which may necessitate repairs. Step 4 involves checking for battery voltage that could ascertain the functionality of the control circuit. Transition the vehicle to the off mode and then jump the SCS line again using HDS. Disconnect the PCM connector A to prepare for testing. Turn the ignition to the on position, but it is crucial the PCM connector remains disconnected. You will then measure the voltage between designated test points. If battery voltage is present at this juncture, it signifies the likely functionality of the IG1 starter cut wire and helps direct further investigation, perhaps suggesting the need to replace a faulty PCM. In the 5th troubleshooting step, you'll perform another continuity check specifically for the starter cut relay 2 control wire. Once more, turn the vehicle to the off position and disconnect the relay circuit board connector. This disconnection is vital, as it allows for the testing of continuity between specified terminals in the PCM and relay circuit board. If continuity is present, this means the wire is intact and functioning properly. However, a lack of continuity suggests an open in the wire itself, thereby requiring repairs to ensure there are no interruptions in the relay circuit for optimal functionality. In the 6th step, your focus shifts to checking the integrity of fuse number A43. This fuse is crucial for the correct functioning of the starter cut relay circuit. Ensuring the vehicle is off, visually inspect or test the fuse to determine if it has blown. If the fuse is determined to be okay, you can move to the next troubleshooting step without issue. However, if the fuse is found damaged, it typically suggests a short in the IG1 starter cut wire that connects the fuse to the relay circuit board. Proper repair of any short, followed by replacing the fuse, is essential for restoring functionality. In the 7th and final step of troubleshooting DTC P16F4, you verify if there's battery voltage present in the appropriate wires. Transitioning the vehicle again to on mode is key, while keeping both relevant connectors disconnected. Assessing whether battery voltage is available tells you if the IG1 starter cut line has continuity. If battery voltage is confirmed, the IG1 starter cut wire is operational, and further action may involve replacing the relay circuit board itself. Conversely, if no voltage is detected, this indicates an open circuit that needs rectification between the specified points, ensuring reliable operation of the starter cut relay system. After conducting all necessary repairs, a thorough verification process is crucial to confirm the efficacy of the actions taken. First, check the diagnostics to ensure that DTC P16F4 does not reappear. This reassures that the underlying problem has been adequately addressed. Additionally, clear any remaining diagnostic trouble codes using the Honda Diagnostic System, HDS. Subsequent to clearing, perform a comprehensive engine start test to ensure everything operates smoothly and reliably. Confirming successful repairs is essential for both the lifespan of the vehicle's starting system and the owner's peace of mind. Conducting preventive maintenance can mitigate potential issues related to the starter cut relay 2 and general starting system function. Regular inspections of the vehicle's electrical system are crucial. Checking for corrosion, loose connections, or any degradation in wiring harnesses can preempt failures. Ensuring all connectors are intact and clean fosters good electrical connections, reducing chances of intermittent faults. Additionally, maintaining the integrity and functionality of the starter cut relay itself will further enhance starting reliability. This proactive approach not only prolongs the life of components, but also ensures the vehicle remains dependable under all operating conditions. In summary, the troubleshooting process for DTC P16F4 is comprehensive and methodical, designed to identify and rectify errors in the starter cut relay 2 control circuit. Each step serves a significant purpose to isolate potential faults, ensuring that each component is functioning as intended. By pinpointing the underlying issues, whether they be electrical shorts, open circuits, or faulty units like the PCM, repairs can be executed effectively. Following the outlined steps not only resolves immediate issues, but also aids in enhancing the overall reliability of the starting system. Regular maintenance and checks are recommended, reinforcing the importance of proactive care to sustain the vehicle's performance over the long term. Please like and subscribe to the channel. See you next time.